Now a few more words before we get to the big picture of what multidimensional scaling does. Well, here we have two objects. These objects are measured along 27 lines. So there are 27 bits of information about these two objects. These two objects are actually work operations in an airfield. So it's kind of, let's say this first object, I1I, is 330, 220, and so forth. So it's, is it used frequently? Very frequently. So the values are either 3, 2, 1, 0. Is it important monetarily? Free, it is. Is it offline or not working frequently? 0. It's almost never. So we can take those bits of information. The first was, is it used frequently? The second is, for instance, is it important monetarily? Third, is it offline often? So these are the bits of information about these operations on an airfield, and we measured them, we've written them down, and now we have the second operation, which is in the beginning quite similar, 330 again, and we want to measure the distance between the two operations. So 27 bits of information here along those first two, and as we see, some are really not the same. 3 and 2 here, 2 and 0 here, so not the same values. Okay, now we already spoke of how to measure the Euclidean distance between the two. Let's see now how to measure the Hamming distance. Hamming distance, namely, what it does, it counts the number of dissimilarities. So it doesn't take this delta squared, which would along this dimension be 2 squared 4. So it doesn't take 4 from this set of two values, but it takes instead just how many differences there are. So this counts as 1, this counts as 1, this here counts as 1, this counts as 1, this counts as 1. So altogether, these two working operations in an airfield have 5 differences. That is, the Hamming distance between the two is 5. Okay, now that we've spoken of what our data looks like, what distance measure we'll be using, Hamming distance as well as Euclidean distance, we are now ready for the big picture of what multidimensional scaling